Hello, everyone. Today, we're going to talk about surfaces. Now, surface, as you might be able to guess from the name, is something that's two-dimensional. You kind of see my example here. Um, it doesn't necessarily have to be something that is totally flat. For example, I could take a piece of paper like this, and I could bend it around kind of circular. I could fold it into different shapes like so. And now I've got something that is maybe a little bit more interesting as a surface. That's definitely an option. The first thing I want to talk about, though, is I want to take this example of the flat thing. And the reason that I want to use that as my example is that I want to be able to describe a surface mathematically. And we do that with something called an area vector. I'm going to go ahead and write an area vector here on our screen. We'll typically use capital A as our letter for the area vector, and it's a vector. So I'm going to put a little vector sign up. The way we can figure out what the area vector is the size of the area vector, the magnitude is the area. How big is the thing? But its direction is going to be given by a vector which is perpendicular to the surface. So something like that, or possibly like that. And you can see that as you change the orientation of your surface in space, you're going to get an area vector that points in a different direction. Now, you might have the question, what if I pick a more interesting surface like this orange? And for that, you can kind of tell that I'm going to need more than one area vector for this surface. For example, here would be an area vector for one part of the orange. But if I go down here to a different part of the orange, I need a different area vector. And each little part of the orange is going to have a slightly different area vector, as you can see. In that case, instead of writing big A on its own, we're going to write dA to represent the area vector at each little point along the orange that is in a different direction. And that dA will still be the size of kind of the local area of that part of the orange, and its direction will still be perpendicular to the object. Some surfaces, like the rind of the orange here, are what we might call closed. They entirely encompass what's inside. I can't get to the inside of the orange without going through the rind of the orange. As you can see here, the area vector is always going to point kind of outward. You can also choose to point inward, but in physics, we always choose for the area vector to point outward from a closed surface. Now, you can also have open surfaces. For example, if I were to peel the orange a little bit and leave it open, now it's no longer a closed surface, it's open, and we'd have an area vector for the little flap of orange here, which is no longer in the same direction as it was when